right, so in the last class, we talked about polar graphs and polar points, how to convert from polar equations to rectangular equations. We plotted um, polar equations on a graph. In this section, we're going to take a look at polar form of a complex number, and we're also going to take a look at trig form of a complex number. Well, trig and polar form are the same. So we're taking a look at complex numbers and complex form, and we're going to take a look at polar form, which is also called trigonometric form. So first we'll look at the complex numbers in a complex plane. And a complex number it's in the form a plus bi. So just give me 1 second. I'm still trying to get situated. All right, a complex number is in standard form, and it's in the form a plus bi. Just want to just bring up one note here. All right, so for complex numbers, okay, they're in the form of a plus bi. Now we talked about a rectangular coordinate system. Here we're going to talk about a complex plane or complex number system. So in a complex numbers, we have a real number, and then we also have this imaginary unit I. So if you were asked to, let's say, plot a complex number, the x-axis, this would be your real axis, and the y-axis would be your imaginary axis. So for example, if you were asked to plot three minus 4i, I'm just going to go out to 5 in all directions. Okay, we were treated much similar to a x and y ordered pair. So the first thing I have is 3 minus 4i. So the first real number part of my complex number is 3. So I'm simply going to go 3 places to the right. Since my complex number is 4, I'm going to go down 4 units. 1, 2, 3, 4. So this is my plot for my complex number 3 minus 4i. So let's say we wanted to plot -3 plus 4i. All right, well, here again, I'm going to start at the origin. Since my real number is -3, I'm going to move 3 places to the left. Since my imaginary unit is +4, I'm going to go up 4. And this will be my plot, -3 plus 4i. Right, so taking a look at the complex plane and vector representations. So just notice here we have the real axis, right, which is our horizontal axis. We have the vertical axis, which is our imaginary axis. So here on the slide, they just sort of plotted some points, 2 minus 3i. So notice we're starting at the origin. Since the real number unit is 2, that's 2 places to the left. Since the imaginary unit is -3, we go down 3. Okay. Now, these PowerPoints were taken from a textbook from a previous course, and some of the things that are on the slide are not actually mentioned. Okay, we don't actually deal with them in our particular problems. All right, so here there's some vector representations that we don't quite deal with in this class. Okay, but here is something that is pertinent, right? We talked about this the last time. We have x and y, right? So those are part of the rectangle coordinate system. So x is equal to r cosine theta, y is equal to r times the sine of theta. We also have that r is equal to the square root of x squared plus y squared. So remember, for our polar coordinates, they're in the form r comma theta, right? So here we're given a formula for r. And we're also given that the tangent of theta is equal to y divided by x. Okay, but I use a slightly different formula. So x is equal to r cosine theta, y is equal to r sine theta. And then we had r is equal to the square root of x squared plus y squared. And theta is equal to the arctangent of y over x. So we use this first set of formulas if we're converting from polar to rectangular. We use the second set of formulas if we're converting from rectangular to polar. Okay. Now we're going to talk about trigonometric or polar form of a complex number. So in this instance, we are converting from a complex number to trig or polar form, and then we'll be able to go the other way around. We'll be able to convert a number that's in trig or polar form into a complex number. So here we have the form of a complex number that's in trig or polar form. So here's the expression. We have r times cosine theta plus I. So here again, this is our imaginary unit I times the sine of theta. And this is called trigonometric or polar form. The number r, that's called the modulus or the absolute value. So in our problems, we're going to see the word absolute value, and we're going to be asked to find the absolute value. The absolute value is r. Right, so this is the formula that we're going to use to find r. We can also find the angle theta, which is called the argument. Right, so the argument is our angle measure. We were also able to use the calculator, and I'm going to bring that up. To find r, and we were also able to use a calculator to find theta. Okay, so just reviewing. And I'm just going to slide this out of the way. All right, so if I were to go into angle, all right, the fifth formula or the fifth function was to find r, and the sixth function was to find theta. Okay, and my screen is reading. So this was also equal to Okay, so that was the fifth function to find R, and the sixth function was to find theta. All right, so before we go any further, we're just going to use the formulas to find R, K, the absolute value. Okay, and what is happening? Okay, it's actually on my screen. All right, so here we're asked to find the absolute value of the given complex number. So we have -3 minus 2i. Okay, so this is going to be our first example. Okay, and my screen is freezing. So that was find the absolute value, or find the absolute value. -3 minus 2i. Okay, now we're not actually asked to plot this, but I will plot this. All right, so keep in mind we're in the complex number system, so our real number is -3. So I'm going to go 3 places to the left. The imaginary unit is -2, so I'm going to go down 2. So this is actually in the third quadrant. Now this is going to become a little bit important later on. All right, so this is our point, -3 minus 2i. I'm asked to find R. So now I'm just going to go back. The complex numbers are in the form a plus bi. They can also be in the form x plus yi. All right, so instead of using a and b as the coefficients, when we talk about trig or polar form, we're using x plus yi. Okay, so that kind of coincides with this absolute value formula. So r is equal to the square root of x squared plus y squared. We're going to substitute x for -3. We're going to substitute y for -2. Okay, so notice I don't use 2i squared. I only use the coefficient -2. If you remember from algebra, if you were to square I, you get I squared, and I squared is a -1. All right, so we don't use I in the calculation, we only use the coefficient. So here we have the square root of x squared, so that's -3 squared plus -2 squared. 3 squared is 9, 2 squared is 4. Right, so we have an absolute value as the square root of 13. Okay, and you all can't see that. So we have the square root of 13. All right, so that's the square root of 13. All right, here you're asked to find the absolute value for this given complex number. So we'll take a look at this one. The square root of 5 plus 6i. All right, so I'll give you a second or so to work this out, and then we're going to return with the solution. I'm just going to write that out. Find the absolute value of 5 plus 6i. All right, so we'll take a look at the solution. So we're going to use a formula. R is equal to the square root of x squared plus y squared. We're going to substitute x for the square root of 5 and y for 6. So we have the square root of x, which is the square root of 5 squared plus 6 squared. And now this is all within the square root. So when you square the square root, the square and the square root cancel. That leaves 5. Plus 6 squared is 36. All right, so the square root of 5 plus 36 is 41. So we have this absolute value as the square root of 41. All right, so again, you all can't see that. So that is the square root of 41. All right. Okay, now we're going to kind of put all of this stuff together and we'll take a look at a problem similar to number 5. Okay, but I got to explain something and just quickly. All right, so we have trig or polar form, so we know how to find R. We're going to take a look at an example in a second where we'll find theta, which is our angle measure. So this is trig or polar form, R times cosine theta plus I times the sine of theta. There is also a compact form, and I want to find that. Okay, I actually don't see it. I'll tell you what, we will actually just take a look at the example on the slide. Okay. All right, so we're going to convert from rectangular form and complex form. They're used interchangeably. So here we're asked to convert from rectangular to trig form. All right, so here are the steps. The first step says to sketch a graph of the number in the complex plane. Determine if it's in quadrants 1, 2, 3, or 4. The second thing you're going to do is find R. The next thing you're going to do is find the angle measure. So we're going to take a look at problem number 5, right? I'm going to talk about this cis thing in just one second. All right, so let's write the complex number in polar form, 6 minus 6i. Write the complex number in polar form, 6 minus 6i. All right. So we're going to follow those 3 steps, right? The first step says that we want a graph. So I'm going to plot 6 minus 6i. Right? So I'm at the origin. Since my real number is positive 6, I'm going to move 6 places to the right. 1, 2, 3, 4, 5, 6. My imaginary number is negative 6i, so I'm going to move down 6 places. 1, 2, 3, 4, 5, 6. So this is 6 minus 6i. So I'm in the 4th quadrant. All right. So I'm going to just write some degrees around my axes. So here I have 0 degrees, or 0 radians, 90 degrees, which is pi over 2, 180 degrees, which is pi, 270 degrees, which is 3 pi over 2, and I complete the circle for 360 degrees, or 2 pi. So if my angle measure is in the 4th quadrant, right, so keep in mind, right, this is where it starts, right, and it passes through that point. My angle measure should be in between 70 degrees and 360 degrees. All right, so that's going to become important once we actually find our angle measure. So that's the first thing we did, is we plotted. The second thing I'm going to do is find R. So the first we plot. The second thing we're going to do is find R. Right, so from our formulas, R is equal to the square root of 6 squared plus negative 6 squared. That's equal to the square root of 36 plus 36. All right, so I'm going to add 36 and 36. And we have 72. So we have R is equal to the square root of 72. Next, we're going to find the angle measure. Okay. So now there was a formula to find the angle measure. So theta is equal to the arctangent of y over x. Right, so y is negative 6 and x is equal to 6. So we have the arctangent of negative 6 over 6, which is negative 1. And this is where we want to be careful. All right, so I'm going to use my calculator. All right, so I'm going to check the mode on my calculator. And I believe they're using radian measure. So I'm going to put in radian measure. So I'm going to make sure I'm in radian mode. I'm going to put in the arc tangent of -1. All right, and notice I get this -0.785, which doesn't correspond to any angle in the unit circle. Okay, so this is one of the nuances of using a calculator, right? So even though it wants the answer in radian measure, once I put in radian measure, I don't actually get the pi that's needed. I sort of get an approximation. I'm going to change the mode on my calculator to degree. I'm going to put in this arc tangent of -1 once again. And notice I get a -45 degrees. So theta is equal to -45 degrees. If I go back to our sketch, and the computer is freezing, right? Okay, notice our angle measure should be in between 270 degrees and 360 degrees. Right? Your direction angle should always be positive. Now we talked about coterminal angles, and coterminal angles, they start in the same spot, they end in the same spot. You can find coterminal angles by adding or subtracting 360. Right? So here I'm actually going to take our angle measure and I'm going to add 360. Right? And I have 315 degrees. Right? So -45 degrees and 315 degrees are coterminal angles. Now, since it wants the answer in radian measure, I'm going to pull up the unit circle, and I'm simply going to find that equivalent, right? So 315 degrees, that's 7 pi over 4 radians. Right, so theta is equal to 7 pi over 4. I could also use the calculator functions 5 and 6. So I'll kind of run through those just using the calculator function. So I'm going to go back into angle. Right, I'm going to use the fifth option. Right, that's to find the absolute value. So I'm going to put in 6 comma -6. Right, so notice it's going to give me an approximation. It's not going to actually give me the square root, which is what I need, but I'm going to use it to check my hand solution. So if I were to put in the square root of 72, right, notice I get the same value. Now I'm going to find the angle measure. So I'm going to go back into angle. I'm going to use the 6 function. I'm going to put in 6 comma -6. Right, I get -45 degrees. Here again, I'm going to add 360, and I have 315 degrees. So we can write this in trig or polar form as six minus 6i can be written as the square root of 72 times the cosine of 7 pi over 4 plus I times the sine of 7 pi over 4, right? And it's important to use the I when you're using the sine term, all right? Because that's what actually makes it a complex number, as we'll see in a second. Now, this can be written in a compact form, right? Instead of writing this out as cosine 7 pi over 4 plus I times the sine of 7 pi over 4, it can actually be written in a compact form called the cis notation. So this can actually be written as the square root of 72 cis, and the cis is an abbreviation for cosine plus I times the sine of 7 pi over 4. All right, so this is nothing more than a compact form of your trig or polar form. Okay, so this is actually what the homework problems want. So I'm going to put that in as the square root 72 cis 7 pi over 4. All right, so that's the square root of 72 cis cis 7 pi over 4. All right, at this time, I would like for you to do, okay, I don't want to leave. At this time, I want you to do number 6. Right, so I'll give you a second or so to do number 6, and then we're going to return with the solution. So I'm actually going to write it on OneNote. Write in trig form. One half plus 1/2 I. All right, so let's take a look at the solution. All right, first we're going to plot. All right, so we're just going to kind of guesstimate 1/2. So I'm going to go one place to the right, and I'm going to go up 1/2. So that we know we're in the first quadrant somewhere. So our angle measure should be in between 0 and 90 degrees. The second thing we're going to do is we're going to find R. So R is equal to the square root of x squared plus squared. So x is 1/2 and y is 1/2. So that's the square root of 1/2 squared plus 1/2 squared. Okay, 1/2 squared, we square the numerator and the denominator, so that's 1/4 plus another 1/4. When we add fractions, we have to have a common denominator, which is 4. So we're going to keep that common denominator and we're going to combine the numerators, right? 1 plus 1 is 2. And then we're going to use the quotient rule for radicals. It says that we can rewrite the numerator and the denominator as radicals. So we have the square root of 2 divided by 2, right, as r. The second thing we're going to do is find theta. So keep in mind that theta must be in between 1 and 90 degrees. So we have theta is equal to the arctangent of y over x. So again, x is 1/2, y is 1/2. So that's going to give us the arctangent of 1, right? Because anything over itself is 1. So 1/2 over 1/2 is going to give us 1. If we put this into the calculator, we have the arctangent of 1, which is 45 degrees, okay, which coincides with the sketch. So theta is equal to 45 degrees. And if we convert 45 degrees to radian measure, we have pi over 4. So we can write this as 1/2 plus 1/2 I as square root of 2 over 2 cis pi over 4. All right, so taking a look at problem number 6. Okay, you all can't see that. Right, we have square root of 2 over 2 cis pi over 4. All right, now next we're going to go the other way around. All right, if we have trig or polar form, how do we convert to rectangular form? All right, so in this example, it says express 2 times the cosine of 300 degrees plus I times the sine of 300 degrees in rectangular form. All right, so in order to do that, I'm just going to work this out on another slide. Convert to complex number form 2 times cosine of 300 degrees plus I times the sine of 300 degrees. So the only thing I really want to do here is I want to find the cosine and the sine values for 300 degrees, and then we will distribute. All right, so this is going to equal to 2, and then I'm going to pull up the unit circle. Okay, I'm going to find 300 degrees, which is in the fourth quadrant. The cosine of 300 degrees is 1/2, right? The cosine corresponds to the x coordinate. The sine of 300 degrees is negative square root of 3 over 2. So I am simply going to substitute that in, right? So the cosine of 300 degrees is 1/2 plus, or I should say minus, or plus. And then the sine of 300 degrees is negative square root of 3 over 2. Don't forget to include your I. So now we're going to distribute. So 2 times 1/2 is 1 minus I times the square root of 3. All right, so we have converted trig form to rectangular form. All right, now let's take a look at number 6. And I think there seems to be a problem with these type problems. Let's take a look at it. So this is 8 cis 7 pi over 6. So that's 8 cis 7 pi over 6. So I'm going to attempt to do the same thing. So we want to convert to complex form. Eight times the cosine of 7 pi over 6 plus I times the sine of 7 pi over 6. Right, so I'm going to simply find 7 pi over 6 in a unit circle. Which is 210 degrees. The cosine is square root of 3 over 2. The sine is negative 1/2. Right. So we have the cosine of 7 pi over 6, which is negative square root of 3 over 2. Plus the sine of 7 pi over 6 is negative 1/2. Now we're going to distribute. So the 8 and the 4, they reduce, 8 and 2 reduce down to 4. So I have negative 4 square root of 3. A positive times a negative is a negative. Okay, and you want to make sure that you always have your I for the second term. So I have minus 4I. So we have negative 4 square root of 3 minus 4I. And I was running into a problem when I actually put this in. So let's see what happens. So we have 4 negative 4 square root of 3 minus 4i. So that's negative 4 square root of 3 minus 4i. Let's see. All right, so at this time, I would like for you to do number 10. All right, that's 3 cis 30 degrees, and you're asked to write that in complex number form. 3 cis 30 degrees. So write in complex form. All right, so let's take a look at the solution. So here we have 3 cis 30 degrees, but I'm going to take it out of this compact form and write it as 3 times the cosine of 30 degrees plus I times the sine of 30 degrees. All right. So I'm going to look in the unit circle. I'm going to find the sine and the cosine for 30 degrees. All right, so for 30 degrees, we have the cosine is square root of 3 over 2, and the sine is 1/2. So we have square root of 3 over 2 plus 1/2 I. So now I'm going to distribute 3. So we have 3 square root of 3 over 2 plus 3/2 I. All right, as our number in complex form. All right, next we're going to take a look at operations with numbers in trig or polar form. I think we're here. Okay, here's the product rule. And if we're asked to multiply complex numbers in trig form, here's the formula. Okay, first off, we must have two numbers that are in trig or polar form. So we have our first number in polar form as r sub 1 times cosine theta 1 plus I times theta sub 1. And we have our second number in trig or polar form as r sub 2 times cosine of theta sub 2 plus I times the sine of theta sub 2. So here's the formula. The formula says in order to multiply the two numbers, we would simply multiply the absolute value, so it's R1 times R2, and we would add our arguments, right? It's theta sub 1 plus theta sub 2. In compact form, this is written as R sub 1 times R sub 2 cis theta sub 1 plus theta sub 2. All right, let's take a look at an example. All right, let's take a look at number 11. All right, it says find z sub 1 times z sub 2. All right, and we're given, let me just write this down, 2 square root of 2 cis 133 degrees and z sub 2 as 4 cis 126 degrees. All right, so we're asked to find z sub 1 times z sub 2. So we're given a z sub 1, that's a number in trig form, and it is 2 square root of 2 cis 133 degrees. Z sub 2 is 4 cis 126 degrees. So z sub 1 times z sub 2, that's equal to r sub 1 times r sub 2, right? So I'm going to multiply my absolute value, so that's 2 square root of 2 times 4 cis, and then we're going to add our arguments. So that's 133 degrees plus 126 degrees. So when we multiply 2 square root of 2 times 4, we get 8 square root of 2 cis. And when we add 133 degrees plus 126, we get 259. so that's 8 square root of 2 and 250. Okay, you guys can't see this. 259. All right. And I'm having trouble with my screens. All right, so that's 8 square root of 2 cis 259. All right, now we're going to take a look at 13. Okay, and on problem number 13, okay, and problem number 14, we are dividing. So I'm going to go back to our notes. And there is a quotient rule for numbers in trig or polar form. So here again, the setup is we must have two numbers that are in trig or polar form. And in this instance, we are dividing. So the rule here says that we divide our absolute value. So it's r sub 1 divided by r sub 2. And then we subtract our arguments. Right? Theta sub 1 minus theta sub 2. So let's take a look at number 13. Right here we have 15 cis 90 degrees and 5 cis 70 degrees. All right, so for this example, we want to find Z1 divided by Z2. Z1 is equal to 15 cis 90 degrees. Z sub 2 is equal to 5 cis 70 degrees. All right, so Z1 divided by Z2, I'm going to divide my absolute value. So it's R1 divided by R2. And I'm going to subtract my argument. So it's 90 degrees minus 70 degrees. So we get 3 cis 20 degrees. All right, so we have 3 cis 20 degrees. All right, so at this time, I'm going to stop the recording.